Hello students, this question is from Instrumentation GATE 2018. Okay, it's a very interesting question that has been asked here. First of all, let us read the question. A is a 3 by 3 matrix such that A square is equal to 0. Find the eigenvalue. So A square is equal to 0. Is nothing but a nilpotent matrix. We call it as a nilpotent matrix because A square is equal to 0. Okay, so for just an understanding, let us consider A is a 2 by 2 matrix. Even though it is given as a 3 by 3 matrix, let us consider A is a 2 by 2 matrix, just for simplicity. So now A square means that again A, B, C, D. A square is equal to 0. So now the resultant matrix is going to be A square plus BC, AB plus BD, again AC plus CD, the last one is BC plus D square is equal to the top 0, 0, 0, 0. So A square plus BC is equal to 0. And then AB plus BD is equal to 0. AC plus CD is equal to 0. BC plus D square is equal to 0. So you'll get that the value of A square plus BC is equal to 0. Right? And the next one is that here you'll get the value of A plus D is equal to 0. A plus D is equal to 0. So now if you observe the matrix A, B, C, D. Now A plus B is nothing but the sum of eigenvalues, isn't it? Whenever you are having a matrix, the summation of the principal diagonal elements is going to be the trace of the matrix. So trace of the matrix is given by A plus B, A plus D, I mean. And here it is given as equal to 0, right? A plus D is equal to 0 because B gets, so the value of A plus D is equal to 0, right? So trace is equal to 0, it means that sum of eigenvalues is equal to 0. Property of the eigenvalue. Second thing is that you got A square plus BC equal to 0. Now if you observe, AD minus BC is nothing but the product of eigenvalues. AD minus BC is nothing but a product of eigenvalues. So A plus D is equal to 0 simply means that A is equal to minus D, or which implies that the value of D is equal to minus A. So if you substitute here, you're going to get the value of D is equal to minus A, minus common, A square plus BC is equal to lambda 1 into lambda 2. So it means that lambda 1 into lambda 2 is equal to 0, which indicates that the two eigenvalues that you're going to have are 0, 0. The two eigenvalues you're going to have are, because product of eigenvalues is 0, sum is also 0, there is only one, two numbers, 0, 0 is going to satisfy, right? So one learning here is that whenever you are considering a nilpotent matrix, A is a nilpotent of degree 2. So whenever you are having a criteria where A square is becoming equal to 0, you can see that the summation of eigenvalues and the product of eigenvalues is equal to 0. It means that eigenvalues of themselves are nothing but 0, 0. Even if it's a 3 by 3 matrix or a 4 by 4 matrix, whatever matrix you're going to have, the eigenvalues are going to be 0 only. Okay, so if it's a 3 by 3 matrix, eigenvalues are going to be 0, 0, 0. If it is a 4 by 4 matrix, it's going to be 0, 0, 0, 0. So all the eigenvalues are going to be equal to 0. So answer for this question is 0. Eigenvalues are nothing but 0. So in case if you have any doubt regarding this question, you can call on this number 080 61 766 222. Thank you.